RF Tep unit, what is it all about? Why do we need it? Where is it used? What does it do? Okay, that is the basic video all about that I'm making today. Basically, RF unit, it's an electronic unit that we make. You do need to display sometimes from any two-way radio, whether it's a portable, home base or a mobile, there is a need to display the actual signal and to actually analyze for the quality and various sort of things that you need to analyze the signal. So it's a must-have sort of device in the RF industry, and even for private individuals. Now, why do we need actually RF unit? Oh, well, RF unit, you can't plug in a portable or any two-way radio direct into any measuring instrument, because measuring instruments, they have got a very, very sensitive inputs. And this sensitive for measuring very, very low RF signals. And this wattage coming out of any two-way radio would be much too powerful, and it would destroy immediately, within a split second, whatever instrument you're actually trying to measure if you connect it direct to the output of any two-way radio. So that's where the RF Tep unit comes in. So from two-way radio, basically gets plugged into the input and then gets fed into the antenna for a permanent basis, or like in my case, I got the dummy load connected to it. And then, of course, from there is a tap-off, which actually now gets plugged into the measuring instrument. In my case, it's a spectrum analyzer. And now I will basically show you, when I key in, how the signal actually gets displayed. So let me just set up here. So if you look at it now, I'm transmitting, okay? Now let me try and zoom. Okay, let's see. Okay, I'm zooming. Okay, now you can actually see it. All right, so if I measure from here to there, when I put my cursor to the top of the actual signal, I can reduce it, of course, or I can increase the actual level of the actual signal displayed on the actual instrument. So I actually measure the actual strength of the signal. And by measuring the strength of the signal, the instrument, most of the instruments will calculate the actual wattage, transmitted wattage, precisely. And it will tell me what is the actual wattage coming out of this particular set that I'm transmitting. And in this case, instrument tells me that it is something like 1.18 watt coming out of this particular, because I'm using a low power, transmitted on this particular set. Let me try, okay, so now that's one of the applications. Now, let me try and increase, watch now when I'm increasing the sort of resolution, and now you can see, okay, now I can actually, you can see all these spikes and things like that, that's actually modulation, frequency modulation. And I can actually see what bandwidth does it occupy, what is the deviation when I actually speak, type of thing, if I zoom more deeper into the actual signal. So it is a very, very essential unit to have in order to be able to display it, whether it's a scope or spectrum analyzer or a wattmeter or digital RF digital multimeter, used for RF applications and so on. So once if the instrument does not have facilities to display the wattage and certain sort of facilities, you can at least measure the strength in dB microvolt or dBm, and then of course you can use a clever sort of conversion charts that actually one gets, and then you can actually look it up. Let me just show you, and you can actually look it up, and negative whatever watt conversion tables type of thing. And of course, there is a lengthy mathematical calculations if you want to go into nitty-gritty and to calculate all sorts of parameters of the signal and so on, which, it's not necessary for ordinary individual, but you do require to see. Now, let me try, and okay, let me display the signal. I'm just going to lower it for a spurious to see how good this set is. Does it generate any noise? Okay, let me just do it this way. Okay. Now, the very first, okay, the FCC rule specifies, okay, this is my transmitted signal. I'm putting it right to the edge, okay, in order to be able to display. Okay, when I key in, watch now what is happening. Can you see over here the little sort of, okay, let me put a bit bigger resolution. Can you see? Okay. I increased the resolution. Okay, you can see this thing overshoots now the actual transmitted signal. Now I'll just magnify the actual screen of the spectrum analyzer. And you can see the, okay, let me put it to the measurement so you can see how much it's actually the spurious, first spurious signal. Should I say first harmonic. Now, the FCC rule specifies that first harmonic has to be at least minimum 40 dB smaller than the intended transmitted signal. And in this case, I can actually measure it when I put this cursor over there, and I can see that it gives me exactly minus 71 dB attenuation, which means this signal, which is the spurious signal, harmonic of the intended transmitted signal, is minus 71 dB smaller, which is 100%, and ICASA, according to the FCC rules, should approve the actual set for usage. The reason why, because it's not generating any noise. So again, I have just quickly demonstrated, look at it over there. Let me magnify again. Again, that's my main signal. Let me do it this way, bring it a bit closer. Okay. Watch now when I increase and zoom and increase. Proportionally, of course, my transmitted signal increases and shoots over the screen, just to show you. Now I'm not transmitting. Now that's my main signal. That's a spurious signal. Harmonic, let's put it that way. And you can see the actual ratio on a normal 1-to-1 sort of scale, how much smaller it is. So on that note, basically I have demonstrated in a very simplistic manner what the RF Tep unit that we make is actually used for. And I had to start making it because quite a few customers actually asked me, please get me one, make me one, and so on. Because unfortunately you cannot somehow buy them locally, and you cannot also even buy them online. Very, very few people to actually supply them. So I decided, let me start making them. And of course, this particular unit, it can be used up to 100 watt. Basically from 1 watt to anything up to 100 watt, for measurements. And, one might say, but yeah, I'm using a 400 watt transmitter and things like that. Oh, well, in order to be able to analyze the signals and to see the quality and spurious emissions and harmonics and modulations and deviation and so on, you do not require more than few watt anyway. Even 1 watt, it's actually 100%. But nonetheless, sometimes to stress the actual transmitters, then up to 100 watt is more than enough to be able to evaluate 99.999% of the actual transmitters, but it's a VHF, UHF, or HF sets for that matter. So on that note, I hope you enjoyed the Batos RF Tep that we make. Of course, they are available ex-stock. And on that note, thank you for watching. Until next time.